you don't know your, sure, I did. Ideally, you are not doing the experiment until you turn in the lab notebook. So if you have to turn in the lab notebook first, you don't know if there is a deviation or not. So ideally, for your lab notebook, you can turn in the way it is. But for your lab report, you just write the deviation. You reference to the for the procedure, you would reference it to the lab manual or the ebook, and for the you just mentioned the deviation if there was any major changes. If there is no major changes, you don't have to include it. Next question, you have 2 questions on the lab notebook. Do we have to write the background theory? No. Lab notebook, the components in the lab notebook is the title for the experiment. If there is any chemical reaction, for techniques, there is really no chemical reactions, but if you do have a chemical reactions, you would write it. For the, so it would be the title for the experiment, chemical reaction, if any, material used, procedure. That goes into the lab notebook. Your second questions, it's not mandatory. You don't have to watch the video for the experiment before the lab time. So today, like around 1:30, when we are done with the pre-lab discussions, I would let you know at that point to go ahead and start watching the video. I try to finish the pre-lab discussions within 1 hour or less, so you have enough time to finish the video during the lab time. I hope I answered that question. So your lab notebook does not need to include any data, just the table. Which data you are going to record, just the blank table is good enough. If you did watch it, it's okay. Okay, so empty table is fine, but you don't have to watch the video or you don't have to include the data. For the lab notebook purposes, you watch it after the pre-lab discussions. That time is mandatory. You watch it, you record your data. When you record, after you record your data, you then you write the lab report, and the lab report it's due week. You have 1 week to turn in the lab report. Okay, let me go back. I have to go back a little up to see the questions. I don't want to lose track of the questions. Did I answer your questions, Tarek? Sammy, you got it this time. I wrote the deviations in the lab notebook. Oh, it's fine. Should I not include in the future since ideally we fill it out? Yes, that's true. You don't have to write it. If you watch the video before and you're done with it, you write the deviation. It's not a problem because it's available. But ideally, you're not turning in until the day of the experiment, which the lab notebook is already past due. You have to upload the notebook before the class. We would just include the empty result chart. Yes, the data table, it's empty at this point. Ideally, you watch the video after, and you don't have to watch it before. If you watch it, there's no problem because it's available. Kylie, since this experiment had 3 parts with separate material and the procedure, I wrote it for each. Is that okay? Yes, it is okay. It's optional. You could have combined it, or you could have separated. It's okay. Craig, can we add our own tables separate from what the procedure outlines? I added a table to record recrystallization effect. For this experiment, if you saw it in the procedure, sure, but we don't have that in the procedure for today's experiment for experiment 1. So your table, it should be based on the procedure for experiment 1 today. So if you find something that usually ebook does not suggest, maybe for the first experiment only, for solubility, it suggests the table, but for any other part, whatever is included in the procedure, you would just write a table based on that. Craig, you also had another question that I said, let's talk about it during the pre-lab discussions today. What was that question you had before that I couldn't answer it? You can use your mic, or you could just type in the chat room. Did I answer your question or no?
Sorry, I was just going to ask, is that one of the questions that I emailed you throughout the past week? Because I'm trying to remember where, because I don't remember it off the top of my head. But okay. I'm trying to...
Yeah. You feel like your question was answered, it's fine. And I said, if you need like additional help, bring the question back to the pre-lab discussion. So I did answer it, but if you have still have question, you can bring it now, so I can actually reference to the D2L. I can share the screen with you.
Okay, thank you.
Okay, Jennifer, on the lab notebook, I see the pre-lab questions. In the lab manual, you mean?
Yes, on the lab manual at the end, I see that there's like lab questions.
Yes, I think I did mention that. Yes, I think I did mention that these questions are very similar to the pre-lab quiz. So you take the pre-lab quiz instead of answering those questions in the book.
Okay.
You don't have to answer those questions in the book because you're taking pre-lab questions, pre-lab quiz in D2L. The quiz is a pre-lab quiz, is due before beginning of the class time.
Okay, perfect. And for the final, the lab report, the formal, I guess NFIU they call it formal lab report. Do we have a formal lab report for every lab that we're gonna do, or is it just like selective ones?
No, every lab has a formal lab report. It just gets easier after you write 1 or 2.
Okay, perfect. Thank you.
You're welcome. Include quantity. You don't have to include the quantity, just the name of the material and just the name. For the procedure, however, you have to include the quantity, how much you are using. Very good. Was the regard to the honor lock, I will okay. About the honor lock, were you able to take the quiz or no?
So that's where I kind of got tripped up. So I was able to go through the whole setup where it like asked you to scan the room and take your picture and do the photo ID and everything. But when I finally
the time that you send me email, okay, the time that you send me email, I went into the quiz setting, and I found out that it was my fault. I did not enable the quiz for honor lock up to that point. And at that point, after I enabled, you were supposed to refresh your page, either log out and come back and go through tutorial and take the quiz again. The quiz still is open, and I want to ask the class if anyone has taken the quiz already or no, using honor lock, the honor lock system check.
I took it, and when I tried doing it I believe the first day of class on Thursday, I got a password and I couldn't take it, but when I took it Saturday, it worked for me with no password.
Okay, because then I actually, Craig sent me an email, and after the email, I actually went and I enabled. And when I enabled, then it should not ask for password. It should be like, it should be auto-generated password, that if you go through tutorial after I enable it. Before enabling, you were right, Craig, it would still ask for password. But after I enabled, then at this point, it should allow you to take it without asking for password if you go through tutorial. If you go straight to quiz, it might give you, again, hard time and asking for password. I would, you know, I don't want you to, actually the quiz is just a 2-3 question quiz. And if anyone gets to take the quiz again today with the honor lock, system check, without a problem going through the tutorial, please let me know, so at least I make sure that it is working. So I want you to go back and check it again, because it would require a refresh. Maybe after I send you the email, you did not refresh it.
Yeah, that's possible, because what happened was I was able to get into like the quiz, quote unquote, but it didn't pop up any quiz questions. It just popped up a blank screen. But I don't think I refreshed my internet browser, so that might have been what was wrong. So I'll try it again.
Yes, if you could please try it again, because I want to make sure it's working. And I'm glad that you brought it up, because otherwise, if I don't enable it, it won't start. Okay, I have one more question for the lab report. Do we have to include all the questions that the lab manual told us to consider? No. If it says consider, we will go through that right now. I'm going to go through the lab, explain about the lab, and ask you guys questions about it. When it says consider, that means when you are writing discussions, these are the hints, what to be included, what you need to include in the discussion part of the lab report. There is no need to type the questions and the answer as part of the discussions. Just keep in mind you can include those points into the discussion part of the lab report. Those questions are not to be turned in. You're welcome. Any other questions that you might have? Anyone might have?
So, Dr. Mamari, just to reiterate, when we're writing down the materials for the lab notebook, it's okay to just list the materials being used, and we don't need to use the quantity. But when we write the procedure, we actually have to write the quantity, whether it be grams or milliliters of the actual procedure, correct?
Exactly, yes. Because for the procedure, you are telling what to do. So you have to say how much and what's the concentration and all that.
Right.
Yes.
And for instance, my question was, when we're writing down materials, let's say we have beakers, for example, do we have to write just beakers, or do we have to write we're using 5?
I mean, that would be kind of optional, but when it comes to procedure, please indicate what size, because it does make a difference. For sometimes you don't want to put like a small quantity in a large beaker, because then the percent error when you are measuring mass, it could be different, because especially when you are transferring the leftover in a larger beaker is going to be much more than if you were using a small beaker. So for procedure, sizes are important. For material, sizes are not. For material and the equipment, you don't have to include the size.
Right.
It's not wrong to include it though, the size of the equipment.
The reason I was asking is because during the experiment, when we were doing the solubility, you just simply put the solvents in a beaker, and the experiment, or you didn't really specify the size. Unless it says it in the lab manual, I can't really tell the size of the beaker.
Just remember the time that you're writing the lab procedure for the experiment, you are referring to the ebook, not to the video. The video comes after. So when you are writing the procedure, please write the procedure based on the ebook. And the solvent, I use the beaker to transfer, and I use dropper to place the solvent into, test it for solubility. I do not test the solubility in beaker, because I cannot, unless it's for just the high temperature, low temperature. That's the only one that I might have done it.
Right, because I included just in the procedure, transferring the solvents in a beaker and using the dropper, and I specified the amounts. It wasn't in the procedure, but I included that as part of the procedure.
Okay, and Craig, when it doesn't say any size in the procedure of the ebook, then you don't have to be worried about the size of the beaker. Okay, I am okay, let me look at your question. Okay, there is an announcement, Teja, from last class, recording of the last class, and I want you to watch that video, recorded video for introduction. So when you go to announcement, it should say recorded introduction. If it just says link for introduction, that has expired. That was just specific to last week. But if it says recorded, you could also go through communication, Blackboard Collaborate, and look for recording and look for the date from last week on the 7th, January 7th, and watch that video before you, be worried about anything else, because if you were allowed to register late, it should have said that you need to catch up, but catching up, it would have been watching that video. We did record the meeting last class. So try to, if any of you joined the class after last Thursday, please go ahead and watch the video first, the recording from last week, and then you can talk about. Okay, very good. Screenshots. Did the experiment 1 ask for screenshots? I don't think experiment 1 asked for screenshots, but if it does ask for screenshots, it would be the same folder as, if you look at the syllabus, it should say is the same folder as the lab report. Okay, same folder as the lab report for that experiment, because assignment folder, they take multiple submission. At least that's how I set it up. So when you go to submit your lab report, you submit the screenshots. Also, experiment 1 did not ask for screenshots. I started asking screenshots, I think experiment 2 or 3. But when you watch the video, if it says take a screenshot now, that's the time that you take screenshots. If it doesn't ask for a screenshot, if the video doesn't ask for a screenshot, you don't have to include any screenshots. The screenshots are exact timing of the video at exact time. So to make sure that students are watching the video, because it gets to a point that asks for screenshots. Okay, I am going to share the experiment from the lab manual. We go to share. Okay, and I'm going to ask you questions. Okay. Jennifer or Caleb, one of you, can you tell me what's the purpose of today's experiment? The title for the experiment is measuring or determining physical properties of organic molecules, selected organic compounds. Okay, that's the title. What is the purpose of this experiment? Why do we measure physical properties? Why do we determine physical properties? First of all, let me know in the chat area or use your mic to tell me you are here. Jennifer, are you here?
Yes, I'm here.
Okay. And Caleb, are you present, Caleb? Caleb, not here? Jennifer, what's the purpose of today's experiment?
Was it the first part that you're asking me or the whole thing?
In general, what's the reason? Why would we even, spend the time to measure or determine physical properties for organic molecules?
Well, we're gonna see the changes between the melting and boiling points of different solubles and solvents.
And how is it going to help us?
I mean, we can see the different, if it turns liquid or solid, or when would it melt.
Okay, that's like learning, practicing technique, how to measure physical properties. And how is going to help us? Valentina, can you add something? How would the physical property help us? It helps us to determine the identity. Okay, very good. Identity of the compound and the purity of our unknown substance. So using physical properties. So with a similar idea, let's say you have a fingerprint and the person is unknown, right? You would be able to, the purpose of using fingerprint is to like identify. Okay. That was Valentino. Okay. The okay. Ashley, how would you use physical property? I'm going to go with like melting point. How would you use melting point to find out the compound is not pure or it is pure? Ashley, are you here? Ashley? Okay, Ashley is absent actually. Okay.
I could answer the question.
Gitania? Yeah, Gitania?
Yes.
How would you find out a compound is pure based on melting point?
If it's pure, it melts sharply or fast, or you get I would say a better sense of what the melting point is. It's this.
Okay. You answered it correctly the first time. If you have a sharp melting, that means your compound is pure. So it indicates that your compound is pure. What is sharp melting? can anyone tell me what does sharp melting means? What type of numbers would tell me that the melting is sharp or is not sharp, if it's broad?
So
What type of melting? What behavior would tell me you have a sharp melting? Yes, Sammy.
So if you were to have a pure substance, it would have a sharp melting point. That would mean that the range of melting point would be much narrower relative to the degrees.
I'm looking for a magic number, yes.
Yeah, so ideally a pure substance would have a melting point of about 2 degrees Celsius in a range.
Range of a 2 degrees Celsius. That means if your compound starts melting, so some of the like few crystals starts melting at 100 degree, by the time the temperature is 102, everything has melted. So that means sharp melting. So if the melting is like 5-10 degree, between the initial melting and final melting of the sample, from the time it starts melting until everything is melted, it's more than 2 degrees. That means your compound is not pure. Now, the more impure the sample is, the wider the range is going to be. So more impure, wider the range. Okay. Anand, could you tell me how would you use melting point to identify unknown compound? Anand, first of all, are you here?
Yes, I'm here. Sorry.
Okay, sure. How would you determine if the compound is the identity of a compound using melting point?
If the melting point of something does not melt at the rate it should be, then the compound, assuming they have a table of like what it should be, is like impure or like has something else going on in it.
No, we talked about the purity already. Now we're talking about identity. How would you identify a compound using melting point? If you look at the similar, concept of using fingerprint, if you have fingerprint, how do you identify the person?
You would look at a table.
You look at the
table
with
the melting points
of known samples. So if you or you can check against the database. The database, we have books that is called CRC. You have Wikipedia online. You have Google. We also have the CRC, and CRC is very old. I have the 48th edition in the lab. I have an 84th and 88th edition in my office. Every year they come up with a new edition of that book, and it gets thicker and thicker and larger in size, the page size. So what happens every year that they come up or they synthesize new compound or they discover a new compound or new element, the property that includes all physical property and some chemical behavior of the compound is recorded in the book. So you can look at the range of the melting, and then you would find like few compounds those are possible for your name of your unknown compound, and then you have to do more experimentation in order to confirm that is the unknown. So by comparing the melting point of the unknown to set of known melting point for known samples, you can identify your compound. Or you could say you compare it to database of the melting point of different compounds. You would find them. And let me put presents for you. Did you register later now? No, you're here. Good. Okay. Alexis, would you be able to tell me anything about mixed melting? When is it used and what does it mean? Mixed melting point. Have you heard about the mixed melting point, the term mixed melting point?
Is the mixed melting point just when it's like an impure compound and it causes the melting point to be lower because there's two substances?
It really, it's you know, theoretically, if your compound is impure, it's going to have broad melting point, but mixed melting point does not refer to that. Mixed melting point is a different term. Is a methodology or use of mixed melting point, is a technique. And when do you use it?
I am not sure.
It's okay. Antonia? Alexander, what's your last name? Okay, Alex.
I think it can tell you if it's like a same substance or a different substance. Is that okay? Yeah.
How would you do that? What would you, under what situation use mixed melting, and what it is one more time?
If you had like an unknown substance and then you knew like what the identity was by the melting point, you could melt that substance and then see which substance it was by telling when it melted. Yeah.
Okay, first you said it better. The first time around it was better.
Yeah.
It's yes, let's say you have an unknown compound and your unknown compound melts at 120 degrees Celsius. Now you look at the table, there is a compound that melts at 122. Compound A melts at 122, and compound B melts at 119 to 120. Now, your unknown melted at 120. These two numbers are too close to your unknown. You don't know, it's hard to say if it's compound A or is it compound B. So when you get to that situation, which is hard to decide between compound A and compound B, because both of them, they are very close to melting point of the unknown, then you would use mix melting. Now, if you mix compound A with your unknown and the melting point stays 120, what does it mean?
Maybe that it's the same compound.
That is the same compound, because if you have, let's say, benzoic acid, you add more benzoic acid to that. Did you make your compound impure?
No.
No. So if you have that compound and you're adding more of the same compound, your compound stays pure. It doesn't make it impure. Now, if your compound was A, unknown was A, now we are mixing with compound B, is going to lower the melting point. So mixed melting point is a technique that is used to determine the melting point of a compound that it's too close to call. Okay, it's too close to call which one it is. Then to confirm it, you would use mixed melting point. Okay, who was Antonia? Okay, Antonia, did you register late? I think I don't have your name on my list.
Yeah, I just got into the class yesterday.
Okay, let me add your name to here. Okay, let's go back to the lab notebook. I'm sorry, ebook. So organic compounds with the physical property, you can measure physical property to identify compounds. You can measure physical properties to determine purity. You can determine the structure of the compound also. So there are three purposes for measuring physical property. Here is where you can actually see this on the first page of experiment 1. Structure, purity, and identity of the compound. We have also spectroscopy techniques. We are not talking about it at this point. We're just talking about the melting point. Purpose of melting point, we talked about already. You determine identity of the compound, and to identify, you compare that the melting point of the unknown to the database of melting points, and you can use it to determine purity of the organic solid. Now, purity is determined by the range of the melting. If it's a wide range, that means your sample is not pure. If it is a sharp range of melting, then your sample is pure. Organic molecules, they melt at relatively low number, at a lower temperature. So it's very versatile. So you can use this technique, and it's very fast technique. You can right away say if your compound is pure or is not pure. So melting point range. Please pay attention to the melting point range. Is the time that you see few crystals melting until the entire sample melted already. So you don't want to lose track of the melting. As soon as you see the few crystals melting and you see some liquid, you record the number. Then you have to monitor it closely until the entire sample is melted. You don't want to leave the meltdown apparatus and come back, because by the time you come back, you have like clear liquid. You don't know when it stopped melting. And sometimes you start talking to your friends and then you forget to record the number. What is going to happen at that point? What are you going to do at that point? Can you take the capillary tube out? Can you reuse the capillary tube? Anifal, can you tell me if you can reuse the capillary tube?
No.
You cannot. And could you please explain why you cannot reuse the capillary tube? What are the possible problems with that? There are a couple of problems, so maybe you can say one, and then Cassandra could tell me another one, another reason. I see, yeah, I hear chat. Okay. You won't get the correct numbers. Okay. As a general answer, it's fine, but a specific answer, why you don't get correct answer, you need to elaborate on that. Why you don't get, what are the possible problems with that? Because temperature lagging behind, that's a different question. I haven't asked that question. This is if you can you reuse the capillary tube? Why can't you reuse the capillary tube? No, reusing of the same capillary tube. Oh, forget about using capillary tube that was used for a different compound. You're right. You cannot use capillary tube. That's like, you know, drinking from glass that someone else used it already. No, you don't use that. But even the same capillary tube, if you heat it up, it changes to liquid. You take it out, because room temperature is lower than the oven of the melt temp, it goes back to solid. My question is, can you put it back and measure the melting point, say that this is solid already, now I'm going back to make it liquid and measure the temperature? Can you do that at that point? Can you reuse the same capillary tube for the same compound? The answer was no, we cannot use it. And the reason we cannot use it, one of the answers, one of the possibilities is on the board now. It says that it's possible decomposition of the compound. What happens if the compound is, and that is one of the correct reasons for that, What happens when you heat up the sample? Organic molecules, they have low melting point and they are very vulnerable and they can decompose. What does it mean, decomposition? That means your compound, if it's an AB compound, the formula for the compound is an AB. When it decomposes, it can change to compound A plus B. It cuts in half. The molecule decomposition takes place. And when it's decomposed, then compound A, which is usually a smaller molecule, is going to vaporize, and you see the vapor coming out of capillary tube, if you pay attention. And compound B, which is the more stable compound, is going to stay in capillary tube. When it goes back to solid, is going to have higher melting point, at least or minimum different melting point than the original compound, because this is a different compound. Because decomposition is a chemical reaction. So the product is going to have different melting point than the original compound. So you cannot reuse the sample. So that's one reason. And second reason is you cannot use it because, again, it's on the board. Simon put it on the board. That's nice. That crystal structure can change. You melt the organic compound. When it goes back to solid, it can crystallize in a different crystalline structure, and different crystalline structure is going to have different melting point. So the melting point is going to be different. So what you do with that, you are going to drop that capillary tube into waste glass container, and then broken glass container. You start with the new capillary tube, new sample of the same sample, and then you would use it. So you cannot reuse a capillary tube. And that was about the range of the melting. So you have to pay attention when you have the initial melting and monitor it until you get the final melting. For melting point, you have general melting, and you have a general procedure, and you have a specific procedure. In your lab notebook, a specific procedure is enough. A general procedure or general points to remember, that's just for the theory and explanation and why you have to pay attention to that. The sample, when you fill up the capillary tube, it must be grinded to make it powdered, completely powdered. And let me see, Elizabeth, can you tell, is Elizabeth here or Elizabeth coming at 3:30? She already told me. Rosie, you here? Ashana, can you tell me why does it have to be powdered? Why the sample needs to be finely powdered before you place in capillary tube? So I let Ashana and Deja to answer this question. Is it Deja or Deja?
It's
because you have to mix properly. Okay. I'm sorry. Do you say, what did you say, Deja?
Yes.
Okay, perfect.
And I think it has to be finely powdered so that it can be easier to use, maybe, to use the sample when it's finely, because if it's too big, you won't really be able to use it properly.
You won't be able to fit into the capillary tube. And Deja, did you register late?
Yes, I did.
Okay, I just need to add your name to the roster. If the size of crystals are too large, it won't fit into the capillary tube. That's one reason. Second, what's another reason for it? Kylie, have you answered questions? Yes? Okay. Maria, if you haven't answered any questions, can you tell me why does it have to be powdered completely, grinded to fine powder before you fit it into the capillary tube? I think we talked about slightly last class. Surface area for even heating. Okay, it's even heating, but the reason is not for surface area, increasing surface area. Even heating, it comes from different. It has to do with different factor affecting it. If you have large crystals, let's say you take a container and you put rocks in there. Okay, when you have rocks in a container, you have a lot of gap, a lot of air space in between, right? But if you put sand in a container, you don't get large space in between. So the finer the size of the crystals are, less space is going to be between the crystals. We talked about air not being a good conductor of the heat last class, and air is not good conductor of the heat. As a result, if you have large gap between the crystals, heat is not going to distribute evenly. Your sample is not heated evenly. As a result, one part is going to dissolve, is going to melt first. The other part is going to dissolve last, and you get, by error, you would get sharp melting instead of you will not get a sharp melting. You will get a wide range of melting, and that is the problem, because air is not a good conductor of the heat and is not going to allow even distribution of the heat. So you won't get the right number recorded. Okay. The answers to most of these questions are in the ebook. Please read the theory part of the experiment carefully. You see, it's just one simple procedure. It's just the melting point. How many questions we could ask? How many different type of questions we could get from this? Okay. It says, your sample must be dry. Why the sample needs to be dry? Most of you have answered questions. So I'm asking second down questions. Why the sample needs to be dry? Correct?
I'm sorry, can you repeat the question?
Yeah, why your sample needs to be dry? What happens if it's wet, if it's mixed with solvent? Let's say your capillary tube is wet or your sample is wet. What would be the problem?
Well, the first problem would be that it would be contaminated with water, so it wouldn't be a pure sample, excuse me. Okay. And the other problem would be that it could potentially dissolve into the solvent, or water in this case, which could cause errors in determining the melting point of the substance.
So the melting point of the substance most likely is going to be lower than the actual, because, as you said, the sample could dissolve. So I'm going to give you examples so everyone understands the difference, dissolving versus melting. Let's say you mix water with sodium chloride, which is a table salt. It dissolves right away at room temperature. But to melt sodium chloride, you have to increase the temperature to 800 degrees Celsius. So it's going to be a huge difference between the melting temperature and dissolving temperature. So your sample cannot be moist, it cannot be wet, it has to be dry, no solvent, because when you heat up, as soon as the temperature of the solvent reaches boiling point of the solvent, it's going to melt the compound in there. So you don't, I'm sorry, it's going to dissolve the compound in there. You don't want to dissolve the compound, you want to melt the compound. So your compound must be dry to begin with. Cannot have solvent because it will dissolve in the residual salt. Tarek, rate of heating. You should heat up slowly your sample. You cannot place the sample and increase the heat to the highest adjustment and expect good melting. What is the problem with fast heating? What would be the problem if you do fast heating?
So if you do the fast heating, you could miss the first drops of liquid, so you won't be able to record the initial melting point. And then, so it's recommended, like if you know that, for example, you know the melting point of a substance, say it's like 50 degrees, it's recommended you could go like at least 10 degrees below, and then you start going slowly, so you can start like noticing the changes and be accurate in your like result.
Okay, that's perfect, but with exceptions that I'm looking for just a specific reason that you said you have to start heating slow. I want you to tell me why you have to heat slow. What's the problem with the fast heating? So your procedure is correct, but the point that we have to have a slow heat. What's the purpose for that?
That's because due to like errors in like the apparatus, it's like the temperature and the actual thermometer and the sample, if you do it too quickly, it's going to be different.
It's going to be different. Jennifer, you had the same response or different?
I mean, if you raise the temperature slowly, it allows the heat to transfer all around and assure that the sample has the same temperature of heat.
As the thermometer, right?
As the thermometer, yes.
Okay, so it has to be a slow heating because you want to make sure that the heat is the change in temperature shown on the thermometer is the same thing as the temperature in the sample. So how does thermometer work? Thermometer has a bulb, right? Has a bulb that it has a liquid in there. When you heat it up, that liquid inside the bulb is going to expand, and when it does expand, it's going to go up in the thermometer, and as it goes up, at one point you read that level of the liquid and you say this is the temperature. Now, if you heat the sample too fast, then your sample is going to melt. So it's just one step for sample is going to melt. But thermometer, first thermometer bulb has to get hot. The increase in temperature is going to expand the volume of the liquid. The liquid is going to start moving up, and by the time it reaches to the proper level, it would stop there. That's like more steps. The reason I say that, because then you remember, hopefully for a longer time, that you have to adjust the level to proper level. But the answer to question is that because the thermometer is lagging the temperature, the actual temperature, in a fast heating. So if you heat up the sample too fast, your thermometer shows lower temperature than the actual temperature your sample feels. So your sample can melt, but the thermometer doesn't show the real temperature. That's why the heating has to be slow heating. So these are some of the points, and I don't know exact page number. It's like page 3 of the experiment 1 that says, first of all, you cannot have your sample, contaminated with solvent, so it has to be dry. The temperature must raise slowly because you want good heat transfer. because you don't want your thermometer to show lower temperature than the actual sample. If you have like quick melting, that's different from the mixed melting. Quick melting, if you don't know the melting temperature, approximate temperature that your sample is going to melt, make like quick melting at the high temperature, and then based on the table that you will see in the video, you can choose what setting your melt temp should be, and then you would set that setting between 0 to 10, between 4 and 5, between 7 and 8, depends how high the temperature is. You choose that number and you set it and let it slowly heat up and read the thermometer. So you want to report two temperatures. One is initial, one is final. Okay. Pay attention to these questions and also to the highlight. I actually added this highlight during the revision for 3rd edition or 4th edition. It says, keep the following questions in mind when you're writing the discussions for your lab report. It doesn't say to answer these questions, but it's saying if you keep these questions in mind, you would write better discussions. Some of these points, like the ones that we just mentioned, why it should be slow heating, why the sample needs to be powdered, why it cannot be wet, it has to be dry. These can go to discussions for your lab report. Use a powder rather than crystalline sample. We already talked about that. Use a new capillary tube for each determination. It's like a used capillary tube or used sample cannot be reused because it can be decomposed. Your sample can be decomposed, or it could have different structure, so you cannot use it. Not heat the sample too rapidly near melting point because the thermometer doesn't show the temperature, the actual temperature. The melting point and the mixed melting, those are procedures. We may not practice, but in theory, you want to know what is the mixed melting, which is going to help a lot when you have like unknown, determining your unknown. Okay, any questions? I promise to keep the pre-lab discussions 1 hour or less. So I'm going to, at this point, ask if you have any questions about the solubility or boiling point, because you are going to watch the video. And the video, because it was like during the live classroom, it's not a short video. So I'm going to let you, after answering your questions, first of all, I need to answer your questions. Second, I need to call attendance. After that, I want you to start watching the video. If you don't remember, or if you from last class, what is due for next week, please go to the syllabus where it says course schedule. It tells you which items are due before 12:30 p.m. on January 21. January 21, like next Thursday, is my birthday too. Yes. My office hours are on Fridays, 9 a.m. Oh, it's tomorrow, 9 a.m. to 10:30. If you do have questions, please attend the office hours. Yes, we do. Questions? No questions? Okay. If you have no questions, I'm going to call for attendance. Tarek was here. Ashley? Ashley? No. Dua? Deja is here. Rosie? Ashana, Jennifer, Alexis, Jennifer, Alexis,
I'm here.
Kylie, yes, Kylie, thank you. Colette, not here. Colette, okay. Valentino is here. Ashley M is not here. Danielle, Maria, thank you. Catania and NFL. Anam, Sammy, Cassandra. Cassandra had a very weak connection today. It could be the AT&T customers. Cassandra, Craig, and Antonia. Okay, because we had a couple of new students who registered after the last class, if I did not call your name, please let me know so I can add to the course, to my roster, to my attendance roster. Is there anyone that I didn't call name today? No? Okay. Any questions for me? No questions.
Yes.
Did anyone try taking the opening the quiz during our pre-lab discussions?
I have a question. So if I go
Yes.
if I go to content and I go first week introduction and experiment 1, that's everything that's due, right? The pre-lab.
Yes, and you can go to content, and then you can go, or you can go to the right side when you are at the course homepage. On the right side, you have the folders, and then for the first week we have 2 folders. One is introduction and one is experiment 1.
Correct. So if we go to experiment 1, the pre-lab experiment 1 quiz, and then we have because you keep mentioning some questions after the video. We have to answer questions, or it's just the quiz in the formal lab?
Okay. There's the pre-lab questions. It's a quiz basically.
Oh, okay. So it's a quiz. Yeah, I took that. Once you log in, it's kind of like short answers that you have to do, right?
Yes, exactly. And for everyone, when you take the quiz, it's the quiz needs to be graded manually. So if it shows a grade of like 0 or 1 or 2, whatever it shows, don't panic, don't worry about it. I have to grade it manually.
Okay. Yeah. I saw it. I believe it's like 6 short answers. And once you submit, it gives you a 0. But yeah, I figured that you needed a grade before anything.
Exactly.
Okay, that's all I wanted to know. Thank you.
Sure. So when you are able to take the quiz, try it as soon as possible for the system check, honor lock system check, and let me know. I just want to hear from someone that it's actually working today as well. I understand that you have to close all other tabs, and I didn't realize that.
I took it last night, and
last night it worked?
Yeah, I didn't have any problems. I took it in.
Okay, perfect. Then it is working. Because it wasn't working before because I did not enable the quiz with honor lock. So now I enabled it, should work. If you don't have any questions, thank you. Have a nice day. And start watching the video for experiment 1.
Okay, thank you. Have a great weekend.
Thank you. You too. Enjoy your weekend. I will see you next Thursday. Thank you.
Excuse me, I have a quick question.
Sure.
Okay, I got added yesterday, and I was looking at the experiment 1 lab notebook, and it ended at 1 o'clock to submit it. And I wanted to know if it's possible that it could be reopened, just so that
For which one?
the experiment 1 lab notebook, because I joined.
Lab notebook. I'm going to open it now.
Okay.
And it will stay open until 11:30 p.m. today. Would that be enough, or should I put tomorrow?
Tomorrow would be better, only because I have to buy a composition book. I don't have one with me. But
if you had a used one from your organic one, you can use it as well.
I actually, when I took organic one, it was at another college, so we didn't even really have. We don't even have an Orgo 1 lab actually, so that's why I'm taking it here. Yeah, but
okay,
I'll definitely be able to. By tomorrow, it'll definitely be done. Everything. That was
sure.
good. Thank you so much.
So I'm going to put it tomorrow at 11:30 p.m.
Okay, thank you.
You're welcome.
Have a great day.
Thank you. Okay, Valentino, do you have any questions for me? Okay, you left.